it should be safe to assume that most everyone knows that the Earth is also called the blue planet because, well, it's mostly blue. A quick Google image search will indeed show the planet in all of its blue splendor, thanks to photos taken from space, either by astronauts from the International Space Station or by the numerous unmanned spaceships that we have launched into outer space through the years. But what makes oceans blue? Here's a couple more stumper. While we're at it, why are oceans salty, and why do they not freeze over even during the winter months? Before we address question number 1, let's review the oceans we've got. According to the National Oceanic and Atmospheric Administration of the US, there are 4 historical oceans: Pacific, Atlantic, Indian, and Arctic. The first is the biggest while the last is the smallest. Just recently, a 5th has been added that is now recognized by most countries: the Southern or Antarctic Ocean. There is also the matter of differentiating oceans from seas. In general terms, a sea is smaller than an ocean and is in fact merely a part of an ocean. Seas are also typically surrounded by land, at least partially. In total, there are around 50 seas in the world. These include bodies of water like the Hudson Bay and the Gulf of Mexico that are not normally considered as seas. Those are a lot of oceans and seas that cover the entire globe, giving the Earth its blue characteristic. Which brings us back to why the oceans are blue in the first place. No, it's not because the waters mirror the blue sky above. The answer is kind of amazing, actually. It has something to do with one unique characteristic of water, which is that it's a color filter. For some reason, water absorbs the red hues from the light spectrum and leaves out the blue parts. So every time light touches the water, it's only the blue color that we see. Sometimes, parts of the ocean will appear red or green or some other color, but that's only because of whatever debris or particles floating on the water that the light bounces off of. Now, what makes oceans salty? Mostly, you can thank the rain for that, and also carbon dioxide. When it rains, the carbon dioxide in the air dissolves, mixing with the rainwater and making it slightly acidic. The acidity is enough, though, to weather rocks, causing the release of mineral salts. These salts, in turn, break down into ions that reach the ocean through runoff water. Most of these ions are sodium and chloride, the 2 ingredients that make up the salt we use for cooking. They are also the most abundant ions in seawater, thus giving the oceans their salty taste. When it comes to the ocean not freezing, technically, it's not really absolute. The North Pole, for example, has a huge area of frozen ocean water, while down below, at the South Pole, there is what experts call compacted snow. But, for the most part, oceans do stay liquid even in the harshest winter. 4 factors combine to make it so. First, it's because ocean water is salty. Salt lowers the freezing point of seawater, meaning it will need to be very, very cold before the ocean starts freezing. Second, the ocean currents keep the water constantly moving. This prevents water molecules from freezing in their position. Additionally, ocean currents bring warm water from the equator. Third, the oceans simply have so much water that it's really hard to take away all the heat from them to start the freezing process. Fourth, the Earth's internal heating keeps the oceans heated from below. Even when the surface of the ocean gets too cold, it's way warmer at the deeper parts. These 4 factors work together to keep the ocean from freezing up. So now you know why the oceans are blue, salty, and would not freeze. We hope you have enjoyed this episode of So That's Why. Don't forget to subscribe to get your daily dose of fun and interesting videos. Thanks for watching.